So today let's take a look at this All Powers portable power station. This is my dad's, and this station failed to work during this last natural disaster in our area, Hurricane Helene, that did devastate our area worse than any storm I have lived through. I live in the Georgia, really close to South Carolina side, and of course some of our fellow friends in North Carolina got it much worse. So here's a few clips of our area, and I will do a video in the near future of more detail and follow-up of all the damage and cleanup.
From the air, the view of Hurricane Helene's toll in Augusta is staggering. Neighborhoods left in disarray from the storm's strong winds, which toppled trees and knocked down power lines. Around the area, damage can be found everywhere. Monday morning, Governor Brian Kemp got a bird's eye view.
This hurricane, it looks like a 250-mile wide tornado has hit. The storm literally spared no one.
Georgia Power says the storm was the most destructive in its history and in some places is essentially rebuilding parts of the power grid.
So 1 month after the storm hit, cleanup is still in full swing. This is just some quick footage of the roads very near me. I imagine that the cleanup and roadside debris pickup will most likely go on for months to come. But this power station failed to work for my dad when he needed it, and I think he's bought this well over a year ago, and it's worked through one power outage, but this time it wouldn't power on at all. Just looking at the unit here, we have our inputs here. This is our input charging jack and our solar charging, and we also have a DC output jack here, like a car outlet jack here. Just has the cover over it like so, and on the front we can see our 4 AC outlets, and if we press the buttons here, nothing activates, the lights, nothing activates, nothing tries to come on. It is like the unit is completely dead, so we hope the batteries are not fully discharged. And by the way, on this side, here's some of our other DC outlets. Looks like we have 3 USB-A and 1 USB-C charging jack here, and also the barrel jack DC outlets. And if we look at the bottom, here is our model number and information. This is the S1500 version 2 and shows a capacity of 1092 watt hours and AC output continuous 1500 watt with a surge of double that, which is impressive, 3000. It actually shows our USB output and DC output information here as well. Looks like up to 100 watt on the type C, so it's showing 2.4 amps on the regular USB out times 3. DC output showing 5.5 amps at 13 volts. That must be the barrel connectors. And then we got the car port outlet at 13 volts also, that is 10.5 amps. So to be a small unit, it packs a pretty good punch, being able to start up to 3000 and surge and runs 1500, so almost good enough to be like one complete AC outlet. Usually when you get to 1800 or 2000 watts output on a device, I consider it about the same as a individual wall outlet of AC. If we look at All Powers, we do see they have moved on from this model, and now you see the R1500, but you don't see the S1500 any longer. We do see where you can buy the solar panels, etc. as a kit. they kind of got on the color scheme here of a lot of the other portable power stations, such as Anchor and of course EcoFlow, a lot of your big name brands, all with this gray and black scheme here, looking very similar. If I do search on their site for the S1500, I do see at least the specs and all do still show up. It absolutely shows sold out, but it is there, and I can look up some of the information as well as even the owner's manual for it, which is very helpful. So kudos to All Powers for keeping that up and active. That's a mighty good thing to do, a good way to do business. So I definitely want to look at this for my dad today and see if we can get this back going, because it's not had a whole lot of use. And I think he had it plugged in and it should have been charged and ready to go. It just was completely dead. I do hear something rattling around in here, which is never a good thing. Hopefully we'll be able to find out what that is. It could be leftover plastic from molding or anything like that, but it definitely is something rattling around. And we cannot wake this unit up no matter what we do, so it seems like we're just going to have to tear into this today. But let's go ahead and let's look at this power supply a little closer. We are 30 volts at 10 amps, so we got a 300 watts input, which in the owner's manual it does show a 300 watt charging input. And then we plug this up to our AC. Make sure I get the display in view here. And we did bump up a little, but I expected the wattage to show a little bit just being powered on, but we do have a blue light, so more than likely we are at least powering on. Let's get our meter on volts DC, and center's positive, outer should be negative, and there we go, 30.1 volts, so that's good. We'll plug it in and make sure it does remain on under load. And I will lift this up just so you can see here the jack is on my left side here, so right here, and that is a loose fitting connection for sure. I know you can't tell, but I tried to show how easy that pulled out and pushed in, and almost no wattage whatsoever. That is not a good sign. I'm gonna try to wiggle it now. I guess it's possible it's just a bad connection here, but no amount of wiggling seems to make a difference in the wattage, and I really don't see any kind of silver tip in there. Let's get a flashlight and just look. I don't see the center pin for this charge connection at all. I know the flashlight's probably washing out the camera, sorry about that. Just trying to look and see if I can see that pin shining, and absolutely not. I do not see the center pin. And this is a 5.5 by 2.1 connector, so it should absolutely have a middle pin. I'm going to remove these rubber feet to see if we have some bolts or screws behind here, and we do. We're going to have some fairly large or long bolts here, it looks like. Go ahead and just quickly remove these 4. Yep, they're very long, so that means it goes all the way through to the top. The top must have threaded inserts. That's a good way to design that. Let's see if the top will pop off now, and there we go. So the top's off just like so. And first off, we see they love using red and black wires. Even going up to the AC outlets, they just use red and black wire, which I guess typically no one would ever see it, but that's just a little odd to me. On the right side is where our battery power is coming into the board, because this top board is our inverter. I'm going to go ahead and get my little mini electric screwdriver from Coweets out and get a number 1 Phillips bit. I'm going to remove these 4 screws from the board on this charger board and just see if I can get this board to lift off. But I don't believe that's going to be a plug-in header. I know it's hard to see on camera. It's just a row of pins there. It looks like a soldered header. It doesn't look like it's going to be a connector at all. So I'm going to remove this screw here for this Anderson power pole solar input and just see if that by chance is holding it down, and it doesn't look like it. I'm going to separate the Anderson power pole just further apart here so I can easily plug up my clips so nothing to touch. We just have that capability to easily separate them, so we're going to do it. If you're not familiar with the Anderson, they just simply slide together like a dovetail interlock. I'm going to put some clips on here and then separate them out. And I'm just going to bring up on my power supply, and I could put it in here on the power jack, but I can also probably just put it in on the solar. The solar should take anything from 12 to 65 volts, 300 watts max input. So I'm going to put my power supply around 30 volts and no more than 4 or 5 amps input, just to see if we can get this thing to take a charge and hopefully wake up. And the good sign is we do wake up and the display is showing. We showing like 157 watts roughly input here, and 0% on the battery, so absolutely got drained too low. So I'm just going to let this go just a few minutes here just to get the batteries somewhat awake, and then we'll move forward with the repair as long as the unit seems to be working. You can see where the jack is broke in the back here, and you see where it goes to the same red wire as the solar. So the positive is the common on the charging input here on this board, and then we got some MOSFETs we go through, as you can see at the top where the black wire goes in for the solar. It goes through that MOSFET, and then our AC charging input on the lower, we also have a similar MOSFET. We can solder in our own jack. I'm thinking about maybe using some XT60s. I already have some of these and I really like them. They are definitely rated for way more current than we need here, so I do trust these to be a better connection. And I do happen to have one that is a panel mount, so I believe this will work out. And just put the XT60 connector, this female like so, on our AC adapter, and then we'll just mount the male like so. We do have plenty of room here, so I don't even have to worry about cutting the wires. I can actually leave the wire length long in case this idea didn't work. But yeah, I think it'll be good just to put it right there, since the batteries do seem to be waking up and taking actual light charge, and hopefully we can get Dad's power station back going. So I have removed 4 bolts and 4 screws here to lift up this case over the battery and what looks to be the BMS board for the battery. And we can see our individual cells here just barely around the edge, and we see a lot of MOSFETs on this BMS, and we see our connections. If we look at the cells themselves, we have 12 across, so I would guess this is going to be 12P, and we have 6, I don't know if you can see that, we have 6 down, so 6 this direction. I'm going to put some high-res photos in the video here as well, so you can see that there's 6 across. So 72 cells, and what I believe is going to be a 6S 12P configuration, and 6S at a maximum 4.2 volts is going to be a 25.2 volts max. If this is as it seems, let's see what the voltage measures at this moment, and 17 volts. So more than likely we were definitely below that 2.8 volts per cell, because we charged it up a little bit, and we just now roughly at 2.8 volts per cell average at 6S. So more than likely this BMS had totally disconnected when it got below 2.7 or so volts per cell. So it looks like the battery protection actually did very well. As soon as we put a little charge to it, it bounced back, like the voltage is holding well. Our connectors all look tight. Very impressed with the build quality on that so far. And by the way, these look kind of like 21700 cells, but All Power states that this power station uses ternary lithium, so usually more expensive than like lithium iron phosphate. They use rare metals, so you're either going to have NCA or NCM, so nickel, cobalt, aluminum, or nickel, cobalt, manganese, respectively. I did not see anywhere where the manufacturer stated if it was NCA or NCM, just that they were ternary lithium cells. We just had our 2 bolts here on each side, and then we had our 4 big ones in the middle to hold this part of the case in place. And then our charge circuit is sandwiched in between with the bottom covered, and then we have our inverter and charge section on top. So I'm going to go ahead and take the charging loose at this time, and we'll work on trying to repair the charging port. I'm going to go ahead and slide this Anderson plug back together so we can put it back on the board. I might just leave it off for now until we get through soldering. This board is going to be very difficult to remove, so probably going to solder it in place. The LEDs work well, and we do see the countdown for the time remaining on charge. All that seems to be at least working. It may not be calibrated exactly right at the discharge, but at least it's working. So I'm going to pop a hole right here. So after drawing the outline out with a pencil, I'm just going to go around and drill a few holes around that outline, just inside of the outline actually. And then after we drill a few holes, I'll just take the cutoff wheel from my Dremel, and I just got it hanging here with a magnet, and I can just take the cutoff wheel here and make most of my cut through. What I have left, I can just take a Stanley knife and just pop it through, because there's not much holding at all. And then try to get this angle right for the XT60. So that's looking pretty close. I need to smooth this out a little bit. I can take a file or One thing good about keeping an old soldering iron around, I use this one pretty much for plastics. We'll just smooth out this hole around the edges for the connector, and that actually fits well. I'm going to go ahead and drill the holes for the 2 screws. This connector has the built-in threads. It's got nuts on the back side, so it'll go around the other way and just screw in. I think that's going to work just fine. Now back on the bench, I'm just going to put a tie wrap here temporarily while I cut the trimmings off the back to smooth this up. I'm going to go ahead and put the screws back in this board since it can't be removed easily. And it's really not worth the trouble to remove everything, so I just apologize. I'm going to be able to solder this, but it's not going to show up well at all because it's down in the hole, covered up with some wires. I'm just going to make sure this still fits, and it does. I'm going to go ahead and solder the wires on, so I'm going to get some flux and put it on the tab of this MOSFET, and also where the red wire connects on the Anderson plug on the board. That is our common positive tie point, as mentioned, for these charging inputs, and the harder one's probably going to be this tab on this MOSFET. I'm going to go ahead and do it first, and hopefully you can see some of this. I'm just simply trying to puddle up some solder here to make a good spot to connect our black wire. And there we go, that's the black wire. We're connected good. And now we'll just do the same thing with the red wire, and we're just going to have to heat up where the other red wire goes on the board. I'm just going to make that a big enough blob where I can get this 12 gauge wire connected. And there we go. We're connected just like that. I know it's kind of hard to see, but I'm going to zoom in and see if you can see that any better. You can see where the red wires are tied together there, and hopefully you can see the black wires tied to the tab of that MOSFET, where the case of the DC charging port also goes. That's why that was so obvious how that went. I'm going to put some higher resolution photos up here as well, and hopefully you can see a little more detail that way. And this is a up close of the red wire connecting to the same point. As you can see, they're common there. That's where the center pin was coming off the charging port and coming down, so that's why we easily knew where that went. And obviously the black wire goes where the case or outer part of the charging jack went. You can barely see it there on the top. That's where it went around with the tab of that MOSFET. Just going to get some alcohol here, and we'll fast forward through a lot of this. Just clean the board up really well. Those photos shown earlier were actually taken after the cleanup. Just thought that was a better place to show it. Obviously it was already clean, and this jack was already installed in those photos. Just going to go ahead and mount the jack with the #1 Phillips screws that comes with it. And as mentioned, the nuts embedded in the back of the plug itself. And there we go. I think that's going to work out just fine. Everything still fits and works properly. I can go ahead and put the screw back in this little Anderson power pole connector. For the solar input, let's go ahead and cut the tie wrap, get the wires in there like so. That's going to work out just fine. The next step is to go ahead and replace the plug on the power supply. Of course, we have it off and have given it time to discharge, so no output voltage on this cord whatsoever, but it's always good to double check. I'm going to cut and leave as much wire as I can because we do have a Firelight core on here that's taking up some space at the end of the cable. But let's just see how good the quality of the wire looks. And it actually looks okay. Looks like copper. It looks like it's in good shape. I do have to put this little back piece on this type XT60, so I probably will have to cut those wires back a little more for that reason. Some of the older ones I had, you just put heat shrink on the back and let it go. But this one does have the nice little cap on the back like so. So let's go ahead and lengthen these up a little bit. Put some heat shrink on, and then the back end of the connector, and there we go. And we'll just solder this on like so. Yep, this one will be red, just like that. I'm going to bring over my board holder. I'm just going to put this connector in here while I tin the wires. And I do get asked about this little board holder a good bit. And I actually do have a quick video talking about it, how handy it is for the money. And then I added the helping hands to it. So if you're interested in that, I have a link to that video up in the upper right hand corner. I'm going to go ahead and tin the XT60 pins as well, just a little bit, and then we can always add some more if we need to. These XT60 connectors always solder really well. This is just my 60-watt iron, but it does have a medium-sized tip. It's actually working really well. I could always use the bigger soldering iron if needed, but with this size wire, it's no problem at all. It does fine. We just got to separate that out a little bit and push this back cover on. Let me get this out of the way and just push down on it. And I heard it pop. There we go. Just pops on like so. And then I can push up the heat shrink. Let's go ahead and shrink that down really quick. And I'm already wishing now to put another bigger piece on first. I'm going to see if I can stretch out this piece just a little bit. See if I can slide it over. And there we go. And we'll shrink it back down. There we go. I think that's a little bit better. Nice. Let's go ahead and plug this into our power meter. Let's double check our polarity before we do anything. We definitely try to keep plus and minus polarity as the XT60 standard. And there we go, 30.1 volts. Keep in mind which is positive. It is the flat side here. So the flat side, let's look over to this flat side here. And let's double check. Make sure that's the red wire, and it is. So always best to double check before we plug it in. And let's see what it does here. Yep, clicking, and yep, we're ramping up. Over 100 watts, 200 watts. Awesome. Almost 300 watts. Make sure that's plugged in good. That AC plug was about to come out of the power supply. See what the front display is saying. Yeah, 293 watts input and 9%. So we are charging. So I'm going to clean a lot of this up. We're going to let it continue to charge, and we'll see how it does. So back now, after a while, the wattage has dropped off on this unit, and I expected this to stay closer to 300 watts, but we're dropping down to around 200. After roughly a quarter of the way charged, about 22% charge. So I'm kind of wondering if this is heat related, maybe a thermal issue, and maybe it has dropped the charging down for that reason. The power supply itself is getting very warm, and the charge controller inside the unit also very warm. So what I think I'm going to do is unplug this and let it cool off, and then in the morning I'm going to start it charging again, and we'll see how it goes. So back now, starting off cool, we've charged all the way to 93%, and it's been a couple of hours and we're still roughly 280 to 300 watts input, so everything is pretty warm, but it is charging well. I am wondering why it hasn't ramped down at this point, since it's getting so close to 100%. I really thought the cells themselves will be needing less energy input. Yeah, back now we're showing like 99% and still 285 watts input. So I'm thinking maybe the calibration isn't quite right, since it did totally discharge and now charging back up, maybe to reset itself, because our input does seem to be a little bit off. Back now we are at 100% and we're showing 0 watts input, but we're actually still showing like it is still charging, so that's a little bit odd. Yeah, the calibration definitely got to be reset on this, assuming it's just to auto calibrate, probably empty to charge and probably charge back to close to empty. Hopefully it'll reset itself. Yeah, still at 280. I don't believe there's anything that we can do about that. We'll give it some time and just see how it goes. So after another 20 minutes or so, we have dropped down to around 150, sometimes bumping up to 200 watts. Just it is modulating, so we must be getting close to charge level. If we look at the screen here, we see 100%. And it's showing like the icon like it is charging and the fans are on, but it's showing 0 input, even though we know that there is input going into the cells. Bring over our meter on DC volts, and let's see from plus to minus here. Yeah, 24.7, so we're getting really close. I don't know if it's going to stop at 25 volts or just a little over, but we calculated 25.2 if we do 4.2 volts times 6 cells. So anywhere around 25 volts will be a typical cutoff. So let's just see how that goes. Back now another 30 minutes later, checking on it, and we're definitely dropping down to very low wattage, at the most like 75 watts, and still shows 100%. So to me, still probably calibrating or calculating The energy input here showing 0 coming in, and we'll bring our meter back over. We're right at fully charged now, so let's see what our voltage level is. 25.1, so yeah, we're really close to fully charged here. So good to see that the wattage has dropped off, and I think we're good to go. Power supply is still warm from that charging earlier, but cooling off a lot. Still 60 to 70 watts. While this is finishing up, I'm just going to take some split loom and cover the wire here where it's just got heat shrink, and going to put a little piece of 1/4 inch right here, and I may come back with a piece of 3/8 and put on the heavier part like so. I'll just come back and tape that with some thin tape, and maybe that'll be better there for strain relief. I just cut down some 33 plus, some little thin strips, and we'll put it on here like so, and hopefully that'll be better. Yeah, we're down now to like 50 watts, so steadily dropping. So I think we're good there. I do want to bring over my quick test and use this to hook up my oscilloscope probes. For right now, I just have it plugged into my kilowatt power monitor, and we're right at 117 volts. So this is just the AC power directly from my house, which I'm so glad to get back after going almost a week without it. I will say the powers are usually a little bit higher than that, but we've had a lot going on with these storms, so I'm just glad to get any of it. If we test this out, we're showing you right at 118 volts, and the sine wave looks good, as we would suspect it to be. Looks good here. We are 60 hertz, and sine wave looks great. Let's go ahead and disconnect, and now we'll take that quick test and we'll unplug it from the AC power at the house, and we'll plug it into the power station, and there we go, like so. And we just hook our oscilloscope probe back up here, and of course I'm using a battery powered oscilloscope. I could also do it with an isolation probe on a benchtop main scope if you wanted to, but this is going to work just fine. I just have to find the AC button. There it is, and let's cut the AC power on, and man, it ramps up very nicely, like a soft start, and 115 volts, which is what it's rated for, and the sine wave looks excellent. Very happy with that. I wasn't sure this was a true sine wave output, but thumbs up all powers. It looks great. We'll cut this off and we'll disconnect all this, double check that everything's working, and we do see our available time on power calculate based on the load. So we cut on our LED lights, for example. Going to go ahead and put the 4 big bolts back in the battery pack, and the 4 on the sides as well. We'll put the inverter back up here, but before we put the top case on, I want to put a little bit of the split loom protectant right here where this ground wire had gotten pinched really close between the fan and the heatsink. And just to show you here, I would doubt the heatsink is true ground. So if I put my meter on ohms here, if we go from the ground terminal itself back up to the heatsink, you see that we have no continuity whatsoever. So that's the reason why I wanted to protect that wire. If you do have one of these, it might be something worth checking yourself, because that could cause a real problem if that wire for the ground did come across that heatsink. We're just going to put our 4 bolts back in the bottom really quick here. Then we'll put our little rubber bumpers back over the bolts and remove my bit that was left in this one. And there we go. And I don't hear that rattle anymore. So it looks like everything is functioning normally. We will check the DC output really quick here. I just cut back the wires on the DC plug that I've taken off, and I'll just use this to check it with really quick. I'm going to order some Anderson power pole connectors as well as some DC jacks, which is sized 2.5 by 5.5 millimeter, like so. This original one that I have was for the charging input, and it was 2.1 by 5.5. So they were just a little bit different. But I'm going to go ahead and plug this in, and we should be getting right at 13 volts out, and excellent. 13 volts on the money. We could still use this jack if we wanted to. It's not the proper size for this output though. I just rigged that up with some Wago inline lever nuts if we did want to use it, but going to go ahead and plug up a USB meter and check our 5 volt output here as well. And there we go, 5.3 volts. Awesome. Move everything out of the way here, and this is what our AC power cord looks like now. So Hopefully this will hold up for a long time. I think this is going to be a big upgrade from the barrel connector that was originally there for the input. That was a weak point on this power station, or at least it was on this one. So I hope this will hold up a lot better with the XT60 than that barrel connector did. I feel a lot better about that connection. And of course you could get by probably, if you have an Anderson connection, you could probably get by with charging it back up on the solar input if you had to. But I felt like this is like an upgrade for the unit. That's why I didn't replace it with the jack like it already had. I just felt like at 300 watts, that probably wasn't the best design idea to put that barrel connector on a 300 watt input. And by the way, this is what that pin looked like in the backing piece from that jack. That's what was rattling around inside, so I'm glad we did get that out. It was moving around, it actually fell out on its own. I found it later. So it does look like a pretty heavy duty pin, but the very back of it just broke completely and pushed out. So I'm going to put a label on here that says charge input, because it's not completely obvious what that plug is now. But I'm going to put some high-res photos of the boards on here in case you're interested. I know my lighting on the bench was not the best in this video, and I also had the camera higher, and I got my head in the way of the light in some cases. But you'll have to excuse just getting over a natural disaster in the area. Everything was not perfect, lighting was not perfect, and I still don't have internet as we speak, but I am starting to record some of this stuff as all the other work is going on everywhere outside in the area. I hope you found this video helpful today. If you did, please like, share, and subscribe. I'm going to have some links to some of the tools and things that was used today on this workbench in case you find some of those items interesting. Any of those links you click on are affiliate links, and they help support the channel, and I greatly appreciate it. You guys all be safe in all this storm cleanup. Please say a prayer for all those in North Carolina that is still affected even today, that got it so much worse than we did. We got a lot of the wind and they got a lot of the water. We're actually going to go on a trip to North Carolina that exact same weekend that it hit. We only canceled the trip when we saw how bad the weather was going to be, like rain and such, and was really planning on being there in the Chimney Rock Lake Lure area, one of our favorite places to visit actually. And so our hearts really go out to all those who are struggling there with the floods, and Chimney Rock and all that area just got totally destroyed. So we definitely lift you up in our prayers and just pray that y'all stay strong, and every day it gets just a little bit easier. So thanks you guys so much for watching, and God bless.